let me remind you of the rules here. So recall. So once we do, I guess after today on Wednesday, I'm gonna come back and do a summary of all the rules. But right now, I just want to remind you of the quotient and the pro rule because those are the ones that are longer. Okay, the other ones hopefully are a little bit easier to remember. But I guess let me write this one because this one is important. What is this? And what is it equal to? Good. We'll be using this a lot, okay? Okay, then we have the product rule. Let me write the shorthand notation. Who can tell me what this is? I gave you a little hint in the video. It's very easy to write it.
Prime.
What is it?
F prime. Times G. Plus F times G prime.
Very good. It's very easy. Just write FG plus FG and then prime here and then prime in the second. That's it. The prime is jumping from one to the other. Okay? It's very easy to remember. And remember the product rule is plus. Okay? The quotient rule is very similar. It has a minus instead of a plus and then it's a quotient. So if you're expecting to get a fraction, what's the denominator of the quotient rule? A G squared. Okay? All right. Let me write it down. And then the quotient rule says, who can tell me what it is?
F prime times G minus F times G prime over G squared.
Good. So at the very least, you need to be able to write something like this down, okay? Because if you don't know the rule, you're not going to be able to use it. Okay? So the first thing is to make sure that you know this. Okay, so now that we have these little rules, let's do some examples. Example, let's see, number one, I guess, so we don't forget. What's the definition?
What?
Oh, the definition of the derivative.
Oh, the limit.
Mm-hmm.
Of f of x plus h minus f of x over h.
Over h, and what's the limit?
H approaches 0.
As h approaches 0. So don't forget that because there will be instances in which you may need it. And since I'm here now summarizing several things, let me summarize something else. Let me write something else. So remember, if you want to find the derivative function at a point, you could just plug in a into the formula we have above, right? That was the original definition that we had. But then I gave you an alternative definition. That's very helpful, in particular when you're working with piecewise functions. So who can tell me which one was that? What's the alternative definition here?
The limit of f of a
Is f of x
minus f of a
minus f of a over x minus a. It's just a difference quotient. The average rate of change from a to x. Okay? This is the slope of the line that connects the point a comma f of a and x comma f of x. And then you take the limit. Okay? All right. So we have seen all of these things. Okay? And we're gonna be using from here these rules for the examples. Okay? All right. So if I was asking you this question, if you didn't know the answer, make sure that you know the answer. Be proactive. Make flashcards, whatever it is. I mean, you guys take biology, all the classes, and you memorize a crazy amount of information. I mean, I've seen you with these packets of biology stuff, memorizing things, and then you tell me you cannot remember 5, 6 little formulas. Okay? Make flashcards. Be proactive. If you don't know this, you're not going to be able to do the questions. Okay? All right. So determine if the function is differentiable at 2. At x equal 2, and then the function is going to be f of x equals 1/2 x plus 1 for x less than 2, and then square root of 2x for x greater than or equal than 2. Okay, so let's do this one together, and then I'm going to give you another one for you to try. Okay, so here the question is, by the way, to figure out whether a function is differentiable at a point or not, that's equivalent of me asking you, does the derivative exist? Okay, differentiability means that you can take derivatives, that the derivative exists. So basically, I'm asking you to find the derivative at 2. Okay, can you find f prime of 2? Does it exist? All right, and that question makes sense because after all, derivative is a limit, and you can ask whether a limit exists or not. Okay, if the limit exists, the function is differentiable. If the limit doesn't exist, the function is not. Okay. All right. Why x equal 2? Well, because this is the troublesome point, right? This is the point where the function changes formula. For example, to the left of 2, this is a line. There's nothing wrong with lines. They have a slope, right? To the right of 2, this is a square root function. There's nothing wrong with square root function. At any point on the square root, you can always find a tangent line. The only exception is the 0, where the graph of square root starts, that you have a vertical tangent line, and then we say that the derivative doesn't exist at that point. Otherwise, you can always find a nice little tangent line. So away from 2, this function is fine. The question is, what about 2? Okay? So how do we do this? Notice that around 2, the function changes formula, right? So none of the rules that we have from above are really going to help us. Okay? So in situations like, because to use those rules, you need to have a formula to work with. So for situations like this, since you need to know what's the formula that you're using, you have to use the limit. Understand this? And not only that, not just the limit, you need to use side limits. Because that's the only way that you know what side you are around 2, so that you know what formula to pick. Yes? Now here, you have two choices. You can use the version with h, but with ax equal to 2, or the second version that I wrote here. The second version is way easier, so I'm going to use that. Okay? Because it's more intuitive. Because you're approaching the point. Over there is h, but you don't see an h in here. So how do you know when you are to the left or to the right? Then that means that h approaches 0 from the left or from the right. That's a little bit more strange. Okay? So this formula is the one that we'll be using for these situations. Okay? All right, so solution. Let me just write here that differentiability at x equal 2 is equivalent to the question, does this exist? If we answer yes, then yes, it's differentiable. If we answer no, then no, it's not differentiable. Okay? So let's find the derivative, and for this we need side limits. So by the way, let me put this is limit as x approaches 2 of f of x minus f of 2 over x minus 2 as a formula in this particular case. And what we're wondering is, does this limit exist? Okay? And for this, we need side limits because I don't know what to write here for f of x. Because we don't know what side we are. Okay? Until we know what side we are, then we can pick a formula. So we need side limits. So let's do it. Limit as x approaches 2 from the right. And then limit as x approaches 2 from the left. Okay, so I'm gonna give you 2 minutes. Try.
Is it 1?
1.
For the first one?
No. All right, let's see. Let's do it together. So first of all, the first thing is that we need to know what formula to use. What formula do we use for the function? The second. Very good. So remember, so to know that, you need to look here. X approaches 2 from the right. So what does this mean about x? So this means that x is bigger than 2. So you should be looking at the greater than 2 part of the formula. Yes? So we have limit as x approaches 2 from the right of the square root of 2x minus, okay, what's the value of the function at 2? 2, very good. F of 2 equals 2. Does everybody see this? Okay. Over x minus 2. Okay, now we have a concrete limit. Let's go for it. So the first thing is always, try to plug in. But then, of course, you plug in here, and what do you get? 0 over 0. So we need to do something. What do we do in this situation like this?
Multiply by the conjugate.
We multiply by the conjugate. So multiply top and bottom by this expression. Yes? All right. So once we do this, remember on top, what is it that we get? As a difference of squares, it's a product of conjugates. So what do we get in the top? 2x minus 4. So remember, you need to square the first one. That will kill the square root, and you get 2x, and minus the square of the second. Yes? Okay. And then in the bottom, we just have the product. Remember, do not multiply. Keep it like this, because after all, our goal is to get rid of this guy. This x minus 2 is responsible for the 0 in the denominator. So we want to cancel it. Don't distribute. Okay, leave it like that. Okay, so what can we do now?
Factor out 2 from the top.
On top, we can factor out 2, and then you can see the x minus 2 popping up, right? So take out 2. And now simplify, and now the issue is over, right? Because the 0 in the top is gone, and the 0 in the bottom is also gone. Do you understand this? So now we take the limit, and what do we get? What do we get in the top? So we have a 2 in the top, and what do we get in the bottom? We get a 4. Does everybody see that? You plug in 2 into the square root, you get 2 times 2, that's a 4. Square root of 4 is 2, plus 2 is 4. So we get 2 over 4, which is 1/2. That's our right derivative, if you will. Questions? All right, so now let's do the same thing, but on the left side. So what do we know about x here? X is less than 2. So what formula should we use? First. So 1/2 x plus 1. Limit as x approaches 2 from the left. 1/2 x plus 1 minus. What's f of 2? 2. Good. Question. If this would have been a 5, what's f of 2?
7 over 2. 6. 2.
It's 2. So the reason why I'm asking is this. F of 2 has nothing to do with f of x. F of 2 is f of 2. It's the value of the function at 2. You understand this? What's the value of the function at 2? What piece do you use to evaluate the function at 2? The second one. I understand that here we're to the left, and the formula here is 1/2 x plus, okay, change it to 5, so plus 5, for example. But still, for f of 2, this is independent to this term. So f of 2, you have to look at your function, and that's the second piece. You understand this? Because it's very easy to, when you're doing this, oh, my formula is the first piece, and then you want to plug into the first piece as well. No. This is independent from this. Here I'm asking you to evaluate the function at 2, and you have to do it. You look and see where is it that it needs to be evaluated. Does that make sense? So be careful. It's just that because it was plus 1, it turned out that no matter what you plug in, you will get it 2, but you need to understand. Okay. So if it was something else, then you have to be careful. Okay, so f of 2 is equal to 2, and then over x minus 2. So let's go for it. So what do we have here? Simplify. So as 1/2 x minus 1 over x minus 2. So again, you cannot just plug in because you're going to get 0 over 0. So what I'm going to do is I'm going to get rid of this little 1/2 by multiplying top and bottom by 2. Yes? Clear denominator. Multiply top and bottom by 2. So we get x minus 2 on top, and then in the bottom we get 2 times x minus 2. Once again, do not distribute the 2 in the denominator because remember, we want to cancel this guy. Okay. So the x minus 2's are gone. So what's the answer here?
So 1/2.
1/2. Right? You get 1 on top and then 2 in the bottom. So now we see the right limit was equal to a half, the left limit is equal to a half. So what can we conclude? The limit exists, and what does it equal to? 1 half. So the derivative of the function is 1 half at 2. Yes? Since two limits are equal, then f is differentiable at x equal 2. And moreover, we can say what it is. This is equal to 1 half. Okay. Questions? Did you understand this? Okay, so let me give you something similar. And this exercise is going to be similar to something that you did in the exam, actually, for continuity, but this time let's do it for differentiability. So find AB such that f is differentiable everywhere. And the function is f of x equals ax cubed for x less than or equal to 2, and then x squared plus b for x bigger than 2. I'm going to give you 5 minutes to try this problem. So remember, at the end of the day, your job is to tell me what must be a and b. Okay, the value for a and the value for b that would make this function differential. So remember, here you naturally need to consider 3 cases. Who can tell me what are the cases that you have to consider? Everyone understand this? These are the 3 situations that you need to cover. Remember, we want differentiability everywhere, so you have to consider all possible points. So, 3 cases. Less than 2 because that's this formula. Bigger than 2, that's this formula, and then 2 is special because it's a point at which the function changes. Okay? So you have to analyze those 3 cases. So let me get you started so you don't get stuck, because there are some subtleties here. Okay, so again, 3 cases. So x less than 2, then we have x bigger than 2, and then x equal 2, we need to deal with that individually. So for x less than 2, what's the formula for the function? Ax cubed, right? Now here, the way you argue differentiability is however you want. What's the easier way to argue differentiability here? Just take the derivative. Okay, you don't have to do limit here. This is a formula now. We can use our rules. Okay, what's the derivative of this?
3a squared.
So in this case, f prime equals, what is it?
3a squared.
3a x squared.
Yeah.
Okay, so 3a x squared. Does everyone understand this? A is a constant. Remember, we don't know what it is, but it's a constant, so it will be a times the derivative of x cubed, which is 3x squared. Right? Regardless of what a is, a can be whatever you want. This is something that makes sense. You can, when you plug in a number here, you're gonna get a number less than 2, right? Because this is when x is less than 2, you're gonna get an answer. Do you understand this? So we could take derivative, that means the function is perfectly fine, so differential. The function is differentiable for x less than 2. Similarly, if x is bigger than 2, what is our formula? X squared plus b. Therefore, what is f prime?
2x squared.
2x. So the derivative of x squared is 2 times x, right? Okay.
B.
What is the derivative of b?
0.
0. Remember, b is a constant. We don't know what it is, but it's a constant. Yes? So the derivative is 2x. And what do we know about this? The derivative exists, therefore the function is differentiable as well. So regardless of what a and b are, in these two cases, less than 2 or bigger than 2, the differentiability of the function does not get affected. Yes? So, of course, the entire issue comes here. At this point of which the function changes formula, what can we say about the differentiability? Okay? Now, here is where I want you to do some work, but now let's talk about this for a second. Or perhaps, actually, no, go ahead and first think about it, and then that way you can understand the discussion better. So we already know it's differentiable regardless of whatever a or b are. It will be differentiable for x less than 2 and for x bigger than 2. The question remains, what about 2? And we want to ensure differentiability. So what should a and b be so that we have differentiability here? Okay? That's what you need to figure out. What can we do? Yes?
We could solve for A and make the derivatives equal to each other.
Okay, why?
Because they have to be equal, or else it's not differentiable.
Technically, you should be taking a limit, right? But the thing is that when you do the limit from the left, that would be the same thing as just taking the limit of this one of the difference quotient, and at the end of the day, you know the result is this one, of that limit. So if I understand this, yes? And then similarly from the right, you know that you're going to end up with this. Now, are you going to make this, or what do you need to do? Do you plug in 2 or you don't? The derivative of those formulas. You cannot solve for a because you're going to have an x in there. Now remember, we're looking for slopes, right? So if you want to take advantage of this formula, this is telling us that as you come close to 2 from the left, this is the formula that tells you the slope. So at 2, the left side is going to give you, what is it, 12a, right? When you plug in 2 here, you're going to get 12a. So when you do the left limit, what you're going to get is 12a. Does everybody understand this? Now similarly, this formula is the one that tells you the slope as long as you are to the right of 2. So as you approach 2 from the right and you're watching the slopes, you know that you're going to get 4. Because you're coming 2 here and you get 4, right? So if you want this limit to exist, we better have the left one to match the right one. Does everybody understand this? Okay, so strategy. The first thing that we will try is we want to make sure that, okay, so I'm going to invent a notation right now. So I'm going to put a minus here. By this I mean the left derivative. Okay, just so because I don't want to write the limit. So the left derivative of 2, we want to make sure that is equal to the right derivative at 2. So let me say that I'm calling this left derivative. I mean, if you want, I can. If it's better for you, I can do this. I just to get it. Okay, it's probably easier if I write like that. It's closer to what you're used to do the limit, right? This would mean left derivative at 2, and it would mean right derivative at 2. Okay? Let me just say here. So left derivative at x equal to, and by this I mean the right derivative. Okay? So the question is, do these two guys match? And then we want to say yes, so we can answer differentiability. Let's see. For these two guys to match, we need to know what they are equal to. So let's see, the left derivative at 2. What's the left derivative at 2? So that would be, let me write so everybody see it. That would mean plugging 2 into the formula for our first case, which is x less than 2. Does everybody understand this? Why I'm using that formula and not something else? Because we're to the left. Okay, so here we get 12a. Okay, good. Now, what's the right derivative at 2?
4.
That will be 2 times 2. Remember, we're plugging in. So what do we get? 4. It's 12a. 4. And then our hope is that these two guys match, right? As you know, this is not going to match unless A is something specific, right? So from here, we get that if we want the two things to be equal, we better declare that 12a equals 4. Right? So what is A? So A better be 1 over 3. Okay, that's good news. We found A. Typically, what happens is that you get an equation involving A and B. Then your job is to go and get another equation involving A and B and then solve the system. Okay? In this case, it turned out that we got A right away. But what do we do about B? I mean, B is gone. Right? In both derivatives. So what do we do about B? You cannot say 0. I mean,
Does not exist. Does not exist.
no, our job is to figure out what B must be to make sure that.
Do you compute the limit of both of them as x approaches 2?
Of what?
Of f.
Why?
To get both limits be included and make them equal to each other.
Why?
So we can find b.
Yeah,
Plug in A.
but why are you thinking about that?
Because you'll get a system of equations.
Okay, but why do you think that's going to work? Why do you think that's a reasonable thing to do? I mean, why would they be equal to each other? What must they be equal to each other? Can the limits be different?
We're looking for the b when they're the same, right?
We want to know B. We want to know A and B, so the function is differential. Now, you're telling me to take the limit of the function, not of the difference quotient. Right? So that's not derivative anymore. That's now the function itself. Why must the side limits agree?
So limit exists, so that it's differential everywhere.
Yeah, but the limit of the difference quotient, not the limit of the function. So the classmate is saying, okay, instead of the difference quotient, let's look at the function itself. That's what you're saying, right? Why?
Because we already found the derivative, so we just need to make sure that we find b.
Yeah, but what tells you that the limits have to be the same, the side limits? So could that, why?
So that it can be differential.
There are continuous functions that are not differential. So remember the absolute value function? At the point that has the peak, it's continuous, but it's not differential. Are you on the right track? How about the other way around? What do we say about differentiability and continuity?
If
it's differential, it has to be continuous, right? Now, we want the function to be differential, right? So in order for the function to be differentiable at 2, we better have continuity at 2 as well. So that's why we can say, well, we need continuity also, therefore the limits better be the same on both sides. Do you understand this? And in this case, we're not going to lose the data about B, because we lose B because when you put derivative, B is gone, because B is a constant, derivative is 0, right? That's why we lose B. But when we analyze continuity, we're not going to lose that data because we're actually comparing the limits and the value of the function, making sure that the limits are equal and all of that business. Okay? So here you have to think about continuity. Naturally. So we already know A, that's good, but now we need to find B, and how do we get it? Well, the thing is that you should not be looking at derivative anymore. Now you need to go deeper. You need to look at continuity. So note, we want f to be differentiable at 2, and so it must be continuous. Also, Rx equal to. Okay, so now we're gonna go to continuity. So this is continuity at a point. There are 3 things that we have to check, right? What are they? What's the first one?
The function is defined at 1.
mean, I asked you this on the exam, the 3 things. Half of you were not able to write this down. I understand why. Okay? Half of you were not able to write this down. So that's why I'm telling you, create flashcards, study appropriately. Okay? So, is the function defined? Is it? What's the value of the function? At 2? 8a. Very good. You have to use the first piece, right? So it's 8a. Now, we already know what a is equal to, so we can go ahead and throw it in, right? So what was a equal to? 1/3. So that's 8 times 1/3, which is a over 3. Yes? Okay, we got that. All right, second. So what's the second condition?
The limit must exist.
The limit must exist. So as the limit as x approaches 2 of f of x exists. Does this limit exist? Does the limit exist? So in this case, remember, we have to use side limits, right? Because that's the point at which the function changes form. Now this is just a function. There is no different quotient here. So limit as x approaches 2 from the left, and then limit as x approaches 2 from the right. Okay, so from the left, remember x is less than 2. So what formula do we use? First one, which is ax cubed. So you do this and we get 8a, right? And if you want, now you can plug in your a here, which is 1/3. So this is really a over 3. Here I'm using the fact that a is 1/3. Everybody okay with this? Now let's go to the right limit. Limit as x approaches 2 from the right. Here x is bigger than 2, so we should be using the second formula, which is x squared plus b. What's this?
4 plus b.
That's 4 plus b. And then what do we do? Are these two things the same? They are not the same unless you tell me what b is, right? And as you know, there is only one b that will do the job here, that will make these two guys equal to each other, and that's the one that we are after. So we want to say yes to the question because we want to have continuity. So we better enforce these two guys to be equal.
So a over 2 equals 4.
So we declare that a over 3 must be the same thing as 4 plus b. Do you understand this? So, here it's a little bit nicer because we were able to find a before, but usually what happens is that because b was gone when we took derivative, then we got a directly. But if b was not gone, like imagine that instead of x squared plus b, I would have written b times x squared. Okay? When you take derivative, the b will survive. Do you understand that? That would be 2b times x. So, typically what will happen is that here you're going to get an equation involving both a and b. You have two unknowns. One equation, that's not enough. You need two equations to be able to solve for your two unknowns. So then you do the continuity business, and here you will get, stop here, because if you don't know what a is, you have to stop here, then you declare that the two things are equal, and then you're going to get the second equation. Do you understand this? You have the two equations, two unknowns, solve the system. That's typically how it goes. Here it's easier because we managed to find a in the derivative step. Yes? Okay. All right. Anyways, we have this now, and we can easily solve for b. So what is b? That will be a over 3 minus 4. And that's 12 over 3, so we get negative 4 over 3. And notice that here, if you want, we can stick condition 3 here also together, because the answer is yes, provided that a is 1/3 and b is negative 4 over 3. Okay? But then, of course, if these two things match, then the limit exists and is equal to a over 3, which is the value of the function. So condition 3 is also satisfied, which is that the limit and the function must agree. Yes? Okay. So that's it. We found our a and we found our b. Questions? Do you understand this? So remember, the thing is that here you need to know what you're doing. You need to know what's happening. Okay? Because it's not like I'm giving you a system, okay, solve it. No, you have to find the system. Then you solve the system. And how do you find the system? How do you get your equations? First, differentiability condition tells you one equation, and then how do I get my second equation? Well, you need to think about it and say, since I want differentiability, I better have continuity first. Okay, because differentiability implies continuous. If a function is not continuous, forget about being differentiable. Do you understand this? So that's where continuity comes into play, and that will give you your other equation. Okay. Questions? No? You have to go to the restroom? Go.
Thank you.
Guys, you have to just go. Okay, so let's move on. Now let's practice quotient and product rules. Okay. So that was second example. Let's do number 3. So find the derivative. Yeah, I may not get to chain root today, but that's okay because just there are many examples that I want to make sure that we discuss. Okay, I'm gonna write here now a bunch of functions so that you get used to this. So again, as I mentioned last time, there are 2 things that you need here. First, you need to know the rule. Second, you have to be able to successfully use the algebra to calculate the derivative. Okay. Okay, before you start working, I want you to tell me what's the strategy. When you see a problem, you need to know what to do. I don't want you to tell me the answer because to know the answer, you have to be able to compute. But at least you have to be able to look at the problem and know what path to take. What is it that I need to do to solve it? So let's see. The first one. What is it that needs to be done?
What's the get rid of 2x squared?
Okay, but I'm glad that you said that, and because I saw this in some of your exams. Can you simplify the x squares here? The answer is a big no.
Because it's just 1.
The answer is a big no. You can only simplify when you have products. Top and bottom, you can only cancel stuff when you have products. Here we have a plus and a minus in the bottom. You cannot simplify those x squares. And you cannot simplify the 4s. I saw this happening in the exam. Do you understand that you cannot simplify here? So basically, for example, you have this a plus b over a plus c. You cannot just do this and tell me that this is bc. No. I don't know how many times. No. Okay? No. Because if you make this type of mistakes, then it's very hard to get a problem correctly. Because calculus is just a tiny step. The rest is just algebra, simplifying and cleaning up your problems. So make sure that your algebra is on point. Okay. So you have to be careful with that. All right. Quotient rule. Yes.
Yes.
Right. Here. What would be the strategy? Yes.
You multiply the 3x by the 8x. Since parentheses,
Yeah. So to distribute, you mean?
distribute the 3x to the other 2 problems.
Okay.
Then you have to solve from there.
What do we do?
Okay. My answer is so okay. Distribute the 3x to 18x squared plus.
Don't tell me answer. Tell me the strategy, steps. Distribute. Okay, good. What will be the next one?
I gotta do that one.
I want you to do it. I want you to tell me what needs to be done. Yes.
X plus 1 to put it to the negative 1 and use the product rule.
Do you know how to do that? Do you know how to do this derivative? If I give you this function, do you know how to do the derivative like that?
It's not the same as
Right now, if I ask you this question, find the derivative of this function, what you should do is write it like this, and then use quotient rule, right? I mean, once we know chain rule, then you can recognize that this is a composition of two functions. The x to a negative 1 function composed with this one, and then you can apply chain rule to this, if you will. Okay? But right now, we don't have that. So right now, you have to use quotient rule. Okay? So, I mean, the point here is that when you look at B, you see a product, so you could say, oh, I'm going to do product rule. That's fine, you can use product rule. It's just that then you will have to deal with this derivative, and you know, when you do this derivative, understand that it's going to be a sum, so you have to do a power rule here and a quotient rule. Yes? So you cannot get away from the quotient rule. But then you have a product rule also. So what you should do probably is distribute the 3x first. That way you don't have to do product rule. It's only a power rule and a quotient rule. Do you understand what I'm saying? Nothing wrong in doing product rule here. It's just you will need to use product rule, and then you have to use quotient rule anyways. So you have two instances in which you could make mistakes. So might as well reduce that by just one instance. Do you understand this? Okay. But you do it however you want. But my advice is distribute, and then power rule on one side, and then the other one will be quotient rule. Yes? That's for B. How about the last one? What will be the strategy? Okay, yes, quotient rule. Make your life easy. Can you do something easy? Yes.
Would you separate it into two different fractions, divided by x squared?
Into three fractions. There are three things on top.
Okay, yeah.
Good. Yes. So here it's easier to just split this into three fractions. Everybody over x squared. Yes. Simplify each of the fractions, and then it's just three power rules that you have to use. Power rule is easy to use. Does everybody agree with this? My point is, if you can avoid quotient rule, avoid it, because it's long and it's very easy. It's messy and it's easy to make mistakes. Okay? Nothing wrong in using quotient rule. You can do it, but then be careful. Make sure that you can simplify appropriately. Sometimes there is no space, like in the first one. Here, you cannot escape the quotient rule. You have to do it. But here, we can split this as three fractions and simplify, and then quotient rule is not going to be needed. So, again, try to develop this strategy. When try to look at problems and don't just sit down and do it. Try to just, this is a good exercise to do. Look at problems and just try to see if you can see how to do it. Okay? That's one exercise that you should do. Don't do it, just see if you can do it. Then, of course, the next step would be, okay, now do it. You have to be able to do it, right? So, you know, if you want to go, I don't know, from here to the nearest Walmart, you'll probably close your eyes and maybe see the route. Yeah, now, can you get in the car and drive? Maybe you don't know how to drive, right? So, that's the second step. But first, have a plan. No GPS. Okay? Do you know how to get to the nearest Walmart? Me neither. I don't know what's the nearest one. I mean, I know where the Walmart is, but I don't know what's the nearest one. Not sure. Okay, anyways, you have a plan. So now do it. At least 8. I'll give you a couple of minutes to try on your own. Then, if you don't remember, here is a quotient rule. So what's F and what's G? This problem? Remember, F stands for the top and G stands for the bottom. Okay? The way I like to read this is derivative of the top times the bottom minus the top times the derivative of the bottom divided by bottom squared. Okay? So when you see me doing the problems, I'm going to be saying these things out loud. And remember to always simplify as much as you can. Okay, let's see. A. So again, everybody understand that quotient rule is needed, right? Okay, so let's do it. Derivative of the top, 2x times the bottom minus the top times derivative of the bottom. What's the derivative of the bottom? 2x divided by bottom square. So the first thing that you need to do is just blindly use a rule. Okay? Now the calculus is done. What comes now? The algebra. Clean up the expression. Okay? So you could decide maybe factor out 2x because then we're gonna have some nice simplifications. It appears, or you could distribute and then combine like terms however you want. Okay? Here I'm gonna factor because I see some nice stuff that will happen here. I'm gonna take out 2x, and then we're gonna have x squared minus 4 minus, now, minus this, right? But you need to understand that that minus is going to distribute over here. Yes? So if you want, you keep the parentheses and then in another step you distribute it, or just do it in one step, if you understand. Okay?
So it's minus x squared minus 4.
Good. Minus x squared minus 4. Does everybody see that? Okay. Over x squared minus 4 squared. Now we see that the x squares cancel, and then we get negative 8 inside the parentheses times 2x. That's a negative 16x on top. So we get negative 16x over x squared minus 4 squared. Okay, questions? Any questions? So, where does this function have a horizontal tangent line? At what value of x? At x equals 0. Remember, horizontal tangent line means derivative is equal to 0. Okay? And in the case of a fraction is 0 whenever the top is 0, and the top is 0 when x is 0. Alright? Okay. Are we okay for the first one? Alright. So the next one. So what was the strategy here? Should we do product rule or distribute first? So let's distribute first. So we can rewrite this as, what is this, 54? 54x to the 5 plus 39x over x plus 1. And actually, if you want, I'm going to do the following. I'm not going to distribute the 3, just because it's a constant, and that way I keep my numbers lower. Okay? So I'm going to keep the 3 there, and then just distribute the x. That way we don't have to deal with big numbers, or not too big. Okay, so now let's take derivative. This is a constant, so this 3 will just be multiplying everything else. Okay, so I'm going to work inside the parentheses, but remember that whatever we do inside the parentheses, at the end, our answer has to be multiplied by 3. Do you understand this? Remember, constant rule. So f prime is going to be 3 times. Now let's work inside the parentheses. So this is a sum, right? So the derivative of sum is the sum of the derivative. What's the first derivative? For the first term, what's the derivative? What rule do we use? Power rule. So that would be, so what is that? 49, right? 90? So that's 90 x to the 4 and plus. And now what do we do for the second one? The quotient rule. Okay, let's go. Derivative of the top? 13 times the bottom minus the top times derivative of the bottom. What's the derivative of the bottom? 1 over
X.
bottom square. Do you understand this? Any questions? Okay, so now let's clean this up as much as we can. So let's see, this is 3 times 90x to the 4. And then, okay, so here I'm going to have 13x plus 13. Yes? But the 13x is going to cancel with this negative 13x. Does anybody see that? So we're only going to have in the top 13 left over. We multiply it with the 1 over here. Let me write it down.
So it's 13 over
13x plus 13
squared
minus 13x over x plus 1 squared. So these guys cancel out. So we get 3 times 90x to the 4 plus 13 over x plus 1 squared. Are we okay with this? Okay, now, since I just asked you for the derivative, you stop here, that's fine. If you distribute the 3, that's fine. But there will be instances in which you will be interested in the second derivative, let's say. If I ask you now, find the second derivative, and so on. So, this is actually a good thing to have for the second derivative. But for example, if I now ask you, find points at which we have horizontal tangent lines, and I start asking you questions about the derivative itself. When is the derivative positive? When is the derivative negative? Those questions will come up in the next chapter. Okay? Just to give you a quick preview, you think about it, what do you think a positive derivative tells you about the graph of a function? Remember, what is our goal? To take a formula and graph it, right? We want to be able to graph any function. So why are we learning about derivative? What do you think the derivative function tells you? It tells you the slope. But the sign of the derivative, what would that tell you? Very good. Positive derivative means that you have a point with positive slopes. How lines with positive slope look like? Going up, right? So whenever, if you want to know when the graph is going up, look at the derivative and figure out when it's positive, right? If you want to go, if you want to know when the graph is going down, look at the derivative and figure out when it's negative. So in the next chapter, you will be doing this, but then you need to solve the inequality this greater than 0 or this less than 0. And to do that, you need to have this as a single fraction first. So that's why instead of stopping here, I'm going to go ahead and combine it so we keep getting practice in how to combine the fractions and so on, okay? Like rational expressions. Okay, so I'm going to keep my 3 there. I will distribute it later, just to keep numbers down. Okay, so I'm going to combine my parentheses. So we need least common denominator. What is it? Actually, let's do it the easier way. The easier way is that two fractions are easy to add when the denominators are the same, right? So let's just make sure the denominators match. Remember, here we have a 1. So all we need is to have an x plus 1 squared down here, right? So we can do that by multiplying top and bottom by x plus 1 squared. Everybody understand this? So I'm going to multiply this by x plus 1 squared, top and bottom. So we get x plus 1 squared, and then in the top we have 90x to the 4 times x plus 1 squared plus 13. Everybody understand this? All right. And now, and just let's see, is it even worth distributing? Yeah, let's just find the final form. So I'm gonna have my 3 times 90x to the 4 plus x squared plus 2x plus 1 over this. And so, okay, I'm gonna distribute the 3 now. So I'm gonna do 2 distributive at once. When I distribute it here, what do I have here? 270. And now that 270x to the 4, I'm gonna distribute it over the parentheses. Oh, hold on, because then you're gonna. Oh, let me just not do it. So 9x to the 6, 90x to the 6 plus 180x to the 5 plus 90x to the 4 plus 13. And then finally we get 270 x to the 6 plus, so what is this, 4, 5, x to the 5 and then that's 39. Okay, these are derivatives. Again, if the question is just find the derivative, you can stop right here at this step. Okay? But the thing is that you need to understand that later on we're going to be doing stuff with the derivative, so you have to be able to simplify fully. So this is a better expression to then find zeros if you need to, find when it's positive, when it's negative, etc. This particular example is actually a pain. It's a degree 6 polynomial in the top. To find the zeros here, you need to use all your calculus technique, rational zeros theorem, and all of that business. And these coefficients are, well, I will factor the 3 to lower the coefficients. But still, this is something that I wouldn't like to do if I need to find the zeros, okay? So when you get to that, of course, the questions would be, the numbers would be more manageable than something like this. But anyways, this is what needs to be done. Okay, questions? No? Okay. And then for the last one that we have written here, let's see. So again, here the strategy will be, instead of using quotient rule, let's simplify. So we can split this as three fractions, and then simplify accordingly. So the first term would be 4x. The second term is negative 2 over x, right? But if you don't mind, I'm gonna write it as 2 times x to a negative 1, so that then we are ready to use our power rule. And then the last term, I'm gonna write it already as x to a negative 2. You okay with this? Yes?
Yes.
Okay. So now f prime is easy. What's the derivative? 4 plus 2 times x to a negative 2, then minus 2x to a negative 3. Right? Remember, you need to subtract 1 from the exponent. When you have an exponent negative, it decreases, but the number in absolute value gets big. Yes. And then, if you want, just write it like that. I mean, here I would just leave it like this. But be mindful that you have to be able to combine these if needed. Okay? You have to be able to combine this. Okay. Questions? Okay. Let's do another one about this one. So what's the strategy here? Okay, so the different rule first, right? So we need to take the derivative of the first one minus the derivative of the second one. Yes? And then when you go to the second term, how do you take this derivative? You use the product rule, right? But you don't use product rule from the beginning. Do you understand this? You first need to take the derivative of this guy minus the derivative of this one. Now, what's the derivative of this one? That is when you use product rule. So give it a try. And write product rule here to remind you. So f times g prime. This is f prime g. Derivative of the first times second plus the first times the derivative of the second. Okay, so y prime is 1 minus, okay, let me write it down and then we do it in the second step. Right? So it's 1 minus the derivative of this product. Now here, let's use product rule. Be careful. What do we have in front? A negative. So what does that mean? That when you do this, we should put a parenthesis because this minus is going to change the sign of everything. Okay? So be careful. Alright, so let's do it. So 1 minus, I'm going to open a parenthesis and I'm going to put my derivative in there because that negative will distribute. Alright, so tell me what to write. Derivative of the first?
3x
times the second plus
X cubed.
first times
Cosine of X.
cosine. Do you understand this? Okay, and now, in this case, there's really nothing to simplify, so all we do is distribute. Negative 3x squared sine minus x cubed cosine. Questions? Okay. So let's see. That was number 3. I guess we put here number 4 because now it's different. And then we're gonna do a phone exercise. Actually, since we're here talking about derivative, let's do the exercise out loud. Is this problem from the book? So let's do question 131. Okay. So this is referring to the picture on top. We don't have a formula. Okay. So problem 131. So we have the function h. And the reason why I picked this one because I wanted to do something with our rule. This one is just a sum. The way that you do 131, same thing that you do for 10. Okay. Because the rules are a little bit different. So it's the function h is the product of two functions, f times g, and instead of giving us a formula for f and g, we're given a picture. As you can see here, the solid line is f and the dotted line is g. Yes? So we should be able to use that picture to answer any question that we are being asked. So we are being asked 3 questions, and it's about derivative. Derivative of h at 1, the derivative at 3, and the derivative at 4. Yes? Okay, so let's do that. So the first thing that we need to do is, let's get an expression for h prime because we don't have a picture for h, right? So let's try to write the derivative of h in terms of derivative of f and g. And then we can use the picture to answer the question, okay? So our first job is to calculate h prime. Now, I wonder... didn't want to copy and paste, but I guess I don't want, because if I say things out loud, some of you might get a little bit lost. So let me do this one. So I want the whole thing. Okay. No. Why is this? This is not supposed to be happening. Right. Close. Open. Okay. It's gonna look a little bit weird, but that's okay. I know, it actually looks nice. I thought it would have those curvy things. Okay, so we have the problem here. Now we can write on. All right, so this is the one that I want to do. Okay, let's do 131. Okay, so the first thing is that we need to find an expression for h, so we can for h prime, so we can find the derivative. Okay, so 131. So we have that h of x is f of x times g of x. So if we want to answer the value of the derivative, we need to have an expression. So let's find it. Who can tell me an expression of h prime? Yes?
It would be f prime of 1, which is just -1.
So this is of x, let's find the derivative first. Because remember, then we need to plug in 3 points. So let's have one expression and then we just plug in every single time. So f prime times g plus f times g prime, right? So now to answer the question, it's just a matter of plugging in whatever we're given into that formula, and then we're good to go. So let's see, for part A, you want h prime of 1, that just means to find this. Do you understand this? Just plug in 1 into a formula. So the whole point is I want to make sure that you know how to find these values from the picture. that's the whole point of this question. So let's see, f prime of 1, what is that?
1.
0. It's negative.
Let's see, I heard different answers.
How do you find it on prime though?
Think.
Negative 1.
I mean, that's why I'm doing this problem, right? so you see, you need to ask yourself, what is the derivative? I mean, I didn't give you a formula, so forget about all those little rules that we have been discussing, right? Now we're back to the concept. What is derivative? Slope. So look at your function, you have a picture. You can wonder, do I know the slope at that point? How does the function look like around 1? How does it look like? The function. It's a line. Do you know how to find the slope of a line? Yes. What do you need to find the slope of a line? So you need 2 points on the line. If you manage to find 2 points, then you're good to go. Does everybody understand this? So around 1, basically, if you think about it, this is an answer value. So this is an answer value function. This is really a piecewise. To the left of 3 has this formula. You can find the equation of this line. And to the right of 3 has this formula. You can find the equation of that line if you know 2 points, which you do. Yes? But we are concerned around 1. So around 1, this is the line that we are looking at. Yes? So the derivative at 1 is just the slope of this line, because as you know, line has constant slope. So the derivative is a constant. The derivative of a line, mx plus b, the derivative is m. Yes? So, what is it?
Negative 1.
Negative 1. Does everybody understand this? It's negative because it's going down, and then you do 1 down and to the right. You are back in the line. Are we good with this? All right. So, negative 1. Okay. G of 1. What's G of 1?
Positive 1.
So 1. Right? And so the point, so you have to look at this point. But G of 1 is the y value. I'm asking you for the y value. It's 1. Okay, plus f of 1. What's f of 1? 3. And what's g prime of 1? What is it? 1. Good. Because around 1 is g prime. It's just that it's a line, and it turns out that it's positive, and the slope is also 1. So in this case, the line and the slope and the value and the derivative coincide, but that's just because of this point. Okay. Anyways, now we have everything we need. So what's the answer? Again, negative 1 plus 3, which is 2. So h prime of 1 is 2. Did you understand this? Okay. Let's try the next one. So remember, we have a formula, just plug in. That's f prime of 3 times g of 3 plus f of 3 times g prime of 3. So who can tell me, what is f prime of 3?
Not exist.
0.
1.
Does not exist.
There's no slope.
Very good. F is not differentiable at 3. Right? We have that little peak in there. Do you understand this? So if f is not differentiable, forget about the problem, because we cannot find this. Do you understand this? Okay. Let's see. I think I have to be a little bit careful with what I just said, because you may have a function that's not differentiable, but then you multiply it with something that makes it differential with the product. This is a silly case, but still, which is times 0, right? You have a super crazy function that you cannot find the derivative, whatever, but you multiply it times 0, and all of a sudden you get 0. So it becomes super differential. So it's not true that if a function is not differentiable, then automatically the product would not be differential. So we have to be careful. It could be that once you multiply f and g, then you don't get you do get something differential. What happens is that then you cannot use this formula, because this formula assumes that both f and g are differential. It assumes that you can find f prime and that you can find g prime. Okay? Because we cannot find f prime, if we want to investigate this question further, this is not good. What should we do? The limit definition. It's what it is. Do you understand what I'm trying to say? We cannot just say that because f is not differentiable, then the product is not differential. I just gave you an example. If the function g would have been 0, and everything was fine, it would be differential. Do you understand what I'm saying? So, probably in most cases, that's what happens. If the function that you're multiplying is not 0, then the product is not going to be differential. But I'm not sure, so what I'm going to do is I'm going to check it. I need to investigate this. Okay? We cannot just say, oh, because f is not differentiable, then. But the thing is that this is not good. Let me just say here, not good, since f prime of 3 does not exist. Okay? F is not differentiable at 3. So if I want to investigate this, I have to take a limit. So this is a point, so we're going to use the fast way. So limit as x approaches 3 of h of x minus h of 3 over x minus 3. Okay? Now, the thing is that you need to understand that h is a product of f times g. Around 3, g is always the same thing, right? It's a constant. Now, granted, we don't know what the constant is. It's 2 point something, but it's a constant. But the thing is that f, we don't know what it is. We need to know whether we are to the left or to the right of 3. Do you understand this? The formula. So that means that I need to consider side limits. By the way, this value here, just to make it easier for our calculations, I'm going to call it C. Okay? Some number between 2 and 3. That's the value that g takes around 3. Okay, so I'm going to do limit as x approaches 3 from the left of h of x. Okay. I can actually, up here, I can write a little bit more. This is f times g. I was not expecting to do this, but that's fine. It is what it is. Okay, so let's do it. So this is f times g minus f of 3 times g of 3 over x minus 3. Okay, let's see what we get. So to the left of 3, that means x is less than 3. Okay. So what do we obtain for f? What's the formula for f? So what I'm asking is, what's the formula of this piece, right? That's a line. What's the slope of this line? -1, so negative x plus b. So what's the b? 4. Good. That was easy, right? Now, since I know I'm going to need it, so let's go ahead and let's find this formula. That's the second piece for f. That's a line. What's the slope of that line? +1. So it's going to be x plus something. Actually, minus, because the y-intercept is going to be down here, right? So the y-intercept is going to be negative. Now, we can either calculate it, or let's use our knowledge. We know the slope is 1, right? I'm doing this to show you little tricks that you should have picked up back in college algebra. Let's find the y-intercept. We can do it easily now. So we are here. We know the slope is 1. Let's just start backing down. So this line is going to keep going like this. 1, 1. You see that? Then 1, 1. We are -1, then 1, 1. So what's the y-intercept? -2. So let me do that quick. Plain like that. Okay, so we have the two pieces. By the way, what I've written here, now you can actually give a definition for f, a more precise definition. This function is negative x plus 4, as long as x is less than 3. Let's say less than or equal to, because at this point it's also this, but it turns out it coincides with the other one. And then the second piece of the function is x minus 2 when x is bigger than 3. Do you understand this? That's the function f. That's f. All right. So back to business. So we are to the left of 3, so we should be looking at the first piece, which is negative x plus 4. Yes? So negative x plus 4. And remember, around 3, g is a constant. Does everybody understand this? G is equal to c. I just decided to call it c. So I'm going to put here c. Okay? And then minus. Now, what's the value of the function at 3? The value of the function f at 3 is 1. And the value of g at 3 is c. So it would be 1 times c over x minus 3. Okay? This is what we get. All right, so let's take this limit. This is a good exercise because here this is gonna take us on different trips as you're about to see. So this is negative cx plus 4c minus c over x minus 3. Actually, I'm gonna factor out the c, and then we're gonna have negative x plus 4 minus 1. So as a negative 3, I'm going to take out the negative, so it's going to be limit as x approaches 3 from the left of negative c times x plus 3, x minus 3. So as 3, I factor out the negative, so you get x minus 3, okay? Okay, the x minus 3 is cancelled nicely. Okay, this was easier than what I was expecting. So we get limit as x approaches 3 from the left of negative c. What is this limit? What is this? Negative c. Yes? So whatever the value of the function g is at 3, at negative, because that's a constant. Okay, good. So we found the left limit. Now that means the left derivative exists. It equals to negative c. Do you understand this? Now let's find the right derivative. So limit as x approaches 3 from the right of f of x and g of x Okay, so in this case, remember, x is bigger than 3. Blue. Because x is bigger than 3, we should be using the blue formula, right? Second piece, which is this one over here, x minus 2, because this time we are to the right of 3. Yes? Okay, so it's x minus 2. Okay, g is still the same thing, is a constant c. Now the value of the function h, which is f times g, it doesn't change, as we mentioned above, regardless of around what side you are, to the right or to the left. The value is the value. So the value is still c. You understand that? 1 times c. That's exactly the same computation that we did above. So is minus c over x minus 3. Now let's try the same thing. So we do limit as x approaches 3 from the right. Then we factor out c. So what do we get? X minus 2 minus 1 over x minus 3. Okay, so things turn out nice once again. What is this? This is equal to 0. Okay, so left limit negative c. Right limit, positive c. When will these two limits be equal to each other? There's only one case in which they will be equal. When is it? What value of c will guarantee that these two things are the same? 0. And that's actually, we can see in this case, that's the only case. If it would have been c equals 0, in other words, if the function g, that's why you have to be careful, because if the function g would have been something like this, imagine that g would have been this function. If the picture would have been like this, then our c would be 0, because around 3 the function would be 0, and then the derivative would exist. Do you understand what I'm saying? It's just that our g, around 3 the c is not 0, okay? It's 2 point something. So we can see that, let's say here, since c is certainly bigger than 2, then it follows that negative c is not the same thing. That's the same thing as c itself, right? They are not equal, and therefore the derivative doesn't exist for h. Okay. So f prime of 3 does not exist. I mean, that's why I told you, you cannot forget the limit definition. We have all these rules, that's very nice, but they work only when you can use them, okay? And in this case, something that probably sometimes you don't think about is the fact that this quotient and this product rule, they assume beforehand that you can do this kind of thing, that you can take the derivative of the little functions. But what if you cannot? Then that just means that you cannot use the rule. Then you are back to square one, which is definition. You have to take the limit. Okay? All right. I'm glad that I put it here because I was planning to talk about this problem, but this part B was nice. Okay, so we got it. How about C? Let's see. Are we safe with C? Does the derivative exist in both cases? Yes, it does, right? So let's write it down. Because this is h prime of 4, we can see f is differentiable at 4 and g is also differentiable at 4. Actually, so let's do C. So we want h prime of 4, so that will be f prime of 4 times g of 4 plus f of 4 times g prime of 4. Okay. All right, so f prime of 4. What's f prime of 4? Good. So that's 1. Times g of 4. What's g of 4?
C.
C. So I'm going to keep it as, okay, let's put C. Or you can keep it as g of 4, okay? Let's keep it as g of 4, but let me just say that this is the C that we made up above, okay? Just to have it nice with that. Okay? Plus f of 4. What's the value of the function of 4? 2. Times g prime of 4. What's g prime of 4?
0.
Very good. Does everybody understand that g prime of 4 is 0? Around 4, g is a constant function. What's the derivative of a constant? 0. Yes? Good. So you see, a bunch of little conceptual points in this question. That's why I was saying this is a nice question. Because there is no algebra. I mean, there is, with the section of part B, that I agree. I would call that one hard because you have to go an extra mile to do it. But A and C are very nice. All right, so 0. So basically, so what's the answer here? C, which in this case, since we don't know what C is, I'm just going to leave it as whatever G of 4 is. Okay? So your answer is C or G of 4, which is the same thing. We cannot say more because we were not told. Maybe you can say it's 2.5, but I don't want to say it because if they don't tell us, don't assume. It looks like it's halfway, but don't assume if you're not told that. Okay. It's just whatever the value of G is up for. Okay. Questions? Did you understand this? Let's see. Tell me 130 is super easy, so do it out loud. Tell me, what's the answer for A, for 130? So that will be f prime of 1 plus g prime of 1, right? Derivative of f at 1 plus derivative of g at 1. What's the derivative of f at 1? Negative 1. Derivative of g at 1? 1. So the answer is 0 for the first one. Yes? So do that quick. How about h prime of 3? You have to go through the same thing that we did before. But if you think about it, now that you know more, this looks like an absolute value, right? So around 3, the thing is that when you find the derivative, the function is going to give you different slopes. To the left of 3, you're getting a slope negative 1. Look at the graph. And to the right of 3, you're getting a slope 1. Yes? So when you add that with the slope of g, so g happens to be 0. So that means that when you take this derivative, you're going to get different values. 1 on one side, negative 1 on one side, 1 on the other. So the derivative is not going to exist. Do you understand this? So you can write out the definition, the limit, and so on, but at the end of the day, you're going to end up something similar that we had before. Okay? So it does not exist. And what's the answer for C?
0.
1. Very good. So f prime of 1, f prime of 4 plus g prime of 4. Now g prime of 4 is 0, so it doesn't count because g is constant around that point. So it's just whatever f prime of 4 is, and it happens to be 1, right? Because looking at this case. Good. So no computations, everything is here, right? Questions like this. So make sure that you understand. Okay. Questions. So today it turned out that we just did example, but that's fine. So we do chain rule on Wednesday. Okay.